Hi, and welcome to this video for Computer Science 4300 Computer Architecture at Auburn University. What I want to do in this video is go over the sort of physical aspects of the Altair 8800 computer that we're using as our example of a mid-70s microprocessor-based architecture for which we wrote a short program to add two numbers in the lectures in class. And you can find on my YouTube channel also a video of running that program from the front panel, which we're looking at here. But what I want to do in this program is really walk you through the pieces of the computer, and we'll fire it up and actually boot the operating system, which is the way a sort of more normal user would have used it back in the day. We did the front panel to illustrate that method of doing things, but in reality, of course, people didn't compute with the front panel as an everyday practice. So here on the front panel, we've got the LEDs that show you the address and data buses and the state of the machine, and the switches to control the number that you're entering and control the execution of the machine. But let's look inside. So this computer is based on the S100 bus. You can see the 18-card motherboard here. I've only populated about the first 8 slots with the 100-pin connectors for the circuit cards because that's sort of more than enough for everything we're going to do. Up in the corner here, I've got a typical S100 card. This is a 1K static RAM board. This was a typical card you would find in these machines in the 70s when semiconductor memory was fairly scarce, and you couldn't just afford to immediately fill the thing up with the maximum addressable memory of 64K. Each of the 8 chips over toward the left hold 1K addresses by 1 bit, so we need 8 chips to store the 8 bits of a byte. And then the circuitry over on the right is the address decode logic and whatnot. Up in the upper right-hand corner, you see a voltage regulator, which gets us to the subject of power supplies. The S100 bus did not have regulated voltage on the bus itself. It provided some unregulated voltages, sort of enough above 5 volts and enough above 12 volts that each card could have regulators for what it needed. It's sort of an odd standard, and later buses went away from it. But in any event, that's why there's a voltage regulator on the card, which you'll see on most S100 cards. The power for this machine is provided by these 2 power supplies, and it's the one thing on this machine that's not really vintage. I should say there's another thing that's not vintage I'll get to in a minute, but a vintage power supply would have been much larger, had a huge transformer, and a bunch of really large electrolytic capacitors about the size of a soda can or something. And so that's one thing we're really not going to use in this machine. This machine is otherwise a close replica of the original. The machine we're looking at was built in 2007, so it's about 20 years old itself, but it is indeed, just in all fairness, not an original MITS 8800 from the mid-70s. However, it's got a lot of sort of nice period details. The CPU card is identical to the CPU card you would have found in the 70s machine. We're not doing anything odd like simulating the CPU with an Arduino or a Raspberry Pi or something. This is the 8080 itself right here. This cable, which is sort of period correct, ribbon cables came later, and I'll talk about why there are actually some ribbon cables in the machine in a minute, but otherwise just some logic on that card to interface with the bus, a crystal to regulate the speed of the CPU, which is 1 megahertz, and like the voltage regulators. All this wiring here interfaces the CPU card to the front panel and the bus. We've got 2 other cards in the machine. The back card here is a dual serial port card. It's also a vintage card. And the interface to the terminal are these three wires here, which go back to a DB25 connector on the back that I've got a 25 pin to 9 pin adapter, and then a 9 pin RS-232 to USB converter, and then that's going to run to my MacBook over here, which we'll use as the terminal. You see these two disk drives here. These are actually not quite period. They're not modern either. They're from the 90s. But they work pretty well, and they work particularly with the floppy disk controller I happen to have, which is this second card here with the fat ribbon cable connecting it. And again, not really period for the early 70s, but it works, and it's more reliable than using big 8-inch Shugarts or something from the 70s. So that sort of walks us through all the stuff there is. We've got the two floppy drives, the serial card, memory and disk interface card, and CPU card, modern power supplies, and the front panel. So let's turn this on and at least boot it up the way a normal user would use it. So we'll turn the machine on. And I actually have to turn the disk drives on as well. They are powered by this little power supply here. And let me just flip that on. Okay. And now we will get a terminal program running on my Mac. This is a program called Serial that shows me the USB interfaces that are providing serial capability. I'll select that, and let me see now. This is hard to do one-handed. I'm going to try to make this window bigger. And I just can't reach all the buttons with one hand. So I'll zoom in here when we want to actually see what's happening in the 24 by 80 screen. This is emulating a VT100 video terminal. Well, let's go back over here to the front panel. We'll reset things, and there's a ROM for this machine starting at address FF00 that can boot from the disk drive. So let me get address FF00 on the bus and click Run. And you can see the activity light on the disk drive, and over here on the terminal we've booted into the operating system, which is CP/M version 2.2. And I can look at what's on the disk drive, type the dir command, disk drive spinning, and there are the files on my diskette. Looks reasonably like what you might see in an MS-DOS command window, and in fact the MS-DOS command window is sort of a descendant of this as far as interface goes. But this is the way people would use the machine back in the day, with a video terminal or a CRT and probably a couple floppies. It was possible to use it with just a tape drive, or a paper tape, which you probably used a Teletype Model 33 terminal to read and write. But from here we would run some sort of program. Maybe we wanted to write basic programs, so we'd run the basic interpreter, or we wanted to write some assembly language code, which we would use an editor. Editors were really primitive at the time, especially for the teleprinters that couldn't even really show you a screen full of data at a time, just a line. And then you would use the assembler and loader to make an executable program. Hopefully I make some more videos showing you what writing a basic program looks like and the assembler tool chain. But for now, this is enough to show us the hardware and how things work on the Altair. So I will see you in the next video.